Hello TSAT viewers. In this class, we will discuss about regression. See, what is a regression and what is a regression lines? Now, in the last class, we have seen the two random variables x and y. They are taking x1, x2, so on up to xn values. Y is taking y1, y2, so on, yn values. We are making the order pairs x1, y1, x2, y2, so on up to xn, yn. Now, when you plot this order pairs on the graph, we will get a scattered plot like this. Now, when you draw a line passing through the points and where all the points are concentrated on and around the line, then this is called the linear regression line. Now, if it is that, we can draw so many lines. But which line is perfect for the data? Now, look at here. Observe, listen to my words carefully. When you draw a line, say y is equal to a plus bx, such that the deviation from each and every point to the line, see that the sum of the squares of the deviations, from each and every point to the line must be minimum. Then we can say that this y is equal to a plus bx line is the best fit, and we can also call it as best regression line. Now, in the mathematical terms, how we can write it? Y minus a plus bx, this is the deviations. Sum of the squares of the deviation, this must be a minimum value. Now, how can you make this a minimum value? We can make this function summation y minus a plus bx whole square a minimum value by using the principle of least squares. So, using this principle of least squares, we will minimize this y minus a plus bx whole square, and we get the two equations to find our two unknowns a and b, which are constants. And these two equations are nothing but our normal equations. We call that as normal equations. Now, we will see what are these normal equations. The first normal equation is summation y, I taking values from 1 to n, is equal to n into a plus summation xi, where I is equal to 1 to n into b. This is the first normal equation. The second normal equation is summation I is equal to 1 to n yi xi is equal to summation xi, where I takes values from 1 to n into a plus summation xi square I taken from values 1 to n into b. So, using these two normal equations, we can find a and b value, and we substitute y is equal to a plus bx equation, then we will get the regression line, which is a best fit. Now, this is how we go mathematically. Now, there is one more way to find the regression lines using our correlation coefficient R. Now, the regression lines using this correlation coefficient R. How we can write this? The first, correlation coefficients using the regression lines using the correlation coefficient R. Now, we have here two regression lines. So, why we have two regression lines here? The question is why we are having two regression lines. Okay, first we will write now we will see the regression lines using the correlation coefficient R. Y minus y bar is equal to R into sigma y by sigma x into x minus x bar. This is one. We can call this as regression line of y on x. Now there is one more regression line, x minus x bar is equal to R into sigma x by sigma y into y minus y bar. We call this as regression line of x on y. Now why we have two regression lines? Why we are having two regression lines here? So see the first one, it is y on x. That means when we want to find the different values of y for different values of x, we will use this line. We will substitute all the values of x's here, then we will get y values. And in order to find the different values of x for different values of y, we use this regression equation. So that is why we are having the two regression equations. Now, this is nothing but the regression coefficient. We call this as small b, regression coefficient of y on x. And we call this as regression coefficient x on y. So we have two regression coefficients, b x yx, b xy. This is nothing but regression coefficient of the line y on x, and this is the regression coefficient of the line x on y. Now, when you observe these two lines, y on x and x on y, these two lines will meet at x bar comma y bar. That is the mean of x and mean of y. They will meet at that point. Now, they meet at x bar comma y bar, which is the mean of x bar and mean of y bar. Now, when r is equal to 1, or r is equal to minus 1, the two regression lines will coincide. These two regression lines will coincide. So that is a property you have to remember. When r is equal to 1 or minus 1, the two regression lines will coincide. Now we will see what is the relation between the correlation coefficient r and the regression coefficients byx and bxy. R square is equal to bxy into byx. We can also write it as r is equal to under root bxy into byx. We can say that correlation coefficient is the geometric mean of regression coefficients. Okay. Now, bxy and byx will be having the same sign. If bxy is taking positive sign, byx will also take positive sign. If it is taking negative sign, this will also take the negative sign. Now, whatever the sign these two regression coefficients are taking, the same sign will be taken by r value also. So if it is negative, bxy is negative, byx also take the negative value and r will also become negative. That means we will put a negative symbol here. Negative symbol here. If these both are positive, r will also consider the positive value. Now, if bxy is greater than 1, that is, if bxy is greater than unity, then byx must be less than unity. ఒకటి greater than 1 ఉంటే ఇంకోటి obvious గా less than 1 ఉండాలి. So that is one of the property. And these regression coefficients bxy and byx are independent of scale but not origin. They both are independent of scale but not origin. This is also one of the important property you have to remember. Now, angle between two regression lines. Angle between two regression lines. So this angle is measured with tan theta, and we have two formulas for this. We will see. This tan theta is given by 1 minus r square by mod r into sigma x into sigma y by sigma x square plus sigma y square. This is one of the measure of tan theta. And we also have one other formula, tan theta is equal to m1 minus m2 by 1 plus m1 into m2, where m1 and m2 are slopes of the regression lines bxy, byx respectively. Now, if r is equal to 0, r is equal to 0 అయితే ఏమవ్వాలి ఇక్కడ? Tan theta will become pi by 2. Tan theta will become pi by 2. That means, when tan theta become pi by 2, that means the both lines are perpendicular, like this. When you consider this, the both lines are perpendicular to each other and they'll meet at x bar comma y bar. Now this is y on x or x on y, whatever the line we are considering. So they will be perpendicular and they will meet at x bar comma y bar point. Now, if r is equal to plus or minus 1, అప్పుడు ఏమవుతుంది? Tan theta will become 0 or it will become pi. That means they either coincide or they will be parallel. So the parallel case we can directly rule out, because these two regression lines has to meet at x bar and y bar. They will meet at x bar and y bar. So when they are parallel, they cannot, that property will not be satisfied. So we'll rule out that they are parallel. We just consider they will coincide. They will coincide like this, one on other. Now, we will see few questions on this regression topic. See the questions. The two regression coefficients are b1 is equal to 4 by 5 and b2 is equal to 9 by 20. Then what would be the value of r? So we can directly get r square is equal to under root b1 into b2. Those are nothing but b xy and b yx, which will be equal to under root 4 by 5 into 9 by 20. 4 ones, 4 5s, it will be equal to 3 by 5, the value is 0.6. So like this you have to solve the questions. Now see the second question. The point of intersection of two regression lines is, it is x bar comma y bar. They'll meet at x bar comma y bar. The regression coefficients are independent of, so I just discussed, they both are independent, the regression coefficients are independent of scale but not origin. So independent of change of scale but not origin. So that is very, very important. Now the geometric mean of two regression lines is, the geometric mean of two regression coefficients is the correlation coefficient, that is r. Now see the questions. These are just conceptual questions. We will see the mathematically how he will ask the questions. The given two regression lines 8x minus 10y plus 66 is equal to 0 and 40x minus 18y is equal to 214. We have to find r. So we have two regression lines and we have to find the value r. First, in order to find the value of what we need, b y on x and b x on y, we have to find out. Now check here. 8x is equal to minus 66 plus 10y. X is equal to minus 66 by 8 plus 10 by 8 into y. So this is the value of b x on y, it is 10 by 8. and same 40x minus 214 is equal to 18y. Y is equal to 40 by 18 into x minus 214 by 18. This is be y on x, that is 40 by 18. Now find r. What is the relation? R is equal to under root over 10 by 8 into 40 by 18. 8 ones, 8 fives, 2 9s, 2 5. It will be equal to 5 by 9, which will be nearly equal to 0.5. Now check the second question. Given regression lines 5x minus 6y plus 90 is equal to 0 and 15x minus 8y minus 130 is equal to 0. Find r. You have to find r value. The same regression lines are given. Now see here, this is a special case. Write down the equation lines first. 5x minus 6y plus 90 is equal to 0. And the second line is 15x, 8y, 130 minus 130 is equal to 0. Now see here. Generally when we are solving the first question, we directly assumed that this is a line on x on y and this is a line on y on x. That's why we got the correct answer, r is equal to 0.5, which is in the limits minus 1 to plus 1. Now check the second question. Now first we consider it is a line on x on y. We write it as 5x is equal to 90 minus 90 plus 6y. X is equal to minus 90 by 5 plus 6 by 5 of y. Now in the same way, write the second equation. 15x minus 13 is equal to 8y. Y is equal to 15 by 8x minus 13 by 8. So this is our b yx. Now I have to find r. R is equal to under root over 6 by 5 into 15 by 8. 5 ones, 5 threes, 2 threes, 2 fours. It will be equal to under root over 9 by 4, which will be equal to 3 by 2, which is equal to 1.5. R is, we are getting 1.5. But is that true? I mean, what is the limits of r? R will take only from minus 1 to plus 1, but it is 1.5. So here our assumption is wrong. We are considering this as x on y and this as y on x. So here our assumption is wrong. So now we will just correct it and again we will do it. 5x minus 6y plus 90 is equal to 0. 15x minus 8y minus 13 is equal to 0. First this equation we have assumed x on y. Now we will consider this as y on x. So equation will become 5x plus 90 is equal to 6y. Y will become 5 by 6x plus 90 by 6. So in the first case we have assumed this as y on x. Now we will consider this as x on y. So 15x is equal to 8y plus 13, x is equal to 8 by 15 into y plus 13. Now find the correlation coefficient r. R is equal to under root over 5 by 6 into 8 by 15. 5 ones, 5 threes and 2 threes, 2 fours. It is 2 by 3. It will get 0.6. Now it is within the limits. So this is our correct assumption, not this. So this kind of situation arises when the two equations are given and we don't know whether which equation is x on y and which equation is y on x. Luckily in the first problem it is our assumption is correct. So whenever you find the correlation coefficient using the two regression lines, check the limits. If r is within the limits, then your assumption is correct. If r is not within your limit, you have to change your assumption and you have to proceed with the next steps. Okay. Now third question, is it possible for two regression lines to be y is equal to minus 1.5 x plus 7 and x is equal to 0.6 plus y? So in our regression constants, regression coefficients by on x and bx on y, we have discussed one property that this both has to consider the same sign. They both has to consider the same sign. Now check it here, y is equal to minus 1.5 into x. So no need of any adjustments, it's directly our by on x. Now y is equal to 0.6 y into 9. So no need of adjustments, it's directly b x on y and this is by on x. So they both are considering the different signs. It is considering the negative sign and it is considering the positive sign. So it is not possible for two regression lines to be like this. Okay, this is how he asks questions in the mathematical way. So we have also seen how he can ask in the theoretical way. So in the next class, we'll start with time series analysis. Thank you.